So I've had several questions about the Exploring Inverse Functions assignment, so I'm going to go ahead and just work through a couple of the questions I've had. The first question people have asked me about is here on problem 5, what this inverse should look like. So remember how when we find an inverse, we switch the x and y. So I'm going to start out with this vertex point right here, which is located at 2, -4. Well, if I switch the x and y, that will become the point -4, 2. So -4, 2 is this point right here. Then I'm going to go ahead and take this point 0, 0. Well, if I switch the x and y there, I get the exact same point 0, 0. So that point's not going to move. Then I'll go ahead and use one more point. Let's take this one right here, which looks like it's at the point 4, 0. If I switch the x and y there, I get the point 0, 4, which looks like this. Now, remember that this point right here, that point 2, -4, was my vertex, which means in my new picture, its inverse, that 4, -2, is going to be the vertex. So if I connect these dots, I end up with a shape that looks like this. Notice how it ends up being a parabola turned on its side. So that's what number 5 should look like. Now if you scroll down and look at problem 11, which is also a parabola, if I take before I start with that, let's go ahead and find the domain and range of this function. So domain, remember, is our x values, all possible x values. So as we head toward the left, notice how our parabola is going to keep going left forever. So on our domain, it goes to -infinity, it goes to the left forever. And as we head to the right, same story, it's going to keep going right forever, so it goes up to +infinity. But if we talk about our range, when we head down on our range, notice that the lowest down this graph ever gets to is this vertex right here at 2. It never ever goes lower than 2. So when I write my range, I know that the lowest my range can ever go is 2. And notice how I wrote that with a squared off bracket, because we actually get to 2. We're not just getting close to it, we actually get there. So I'm going to use a squared off bracket for my 2. Then heading up, once again, notice that the highest up that this graph ever goes is +infinity. So those are the domain and range of the original function. Now I'm going to go ahead and find the inverse, and I'm going to do that in red, and then we'll find the domain and range of our inverse. So if I take this vertex point, which is located at 0, 2, if I switch the x and y, I get the point 2, 0, which is right here. Then I'm going to choose another point. Let's take this point right here, which looks like it's at -2, 6. If I switch the x and y, I get the point 6, -2, which is right here. And I'm going to use one more point. Let's use this point right here that's at 2, 6. If I switch the x and y for that point, I get 6, 2, which is this point right here. Once again, if I graph these points, I get a parabola that's been turned on its side. So let's talk about the domain and range here. Domain is our x values left to right. So heading to the left, can you see how the farthest to the left our graph ever goes is this point right here at 2? We never go further left than 2. So I know that my domain, the lowest x value I get to is +2. And the range heading to the right, notice, keeps going forever, so that's going to be my +infinity. Now if we talk about the range up and down, well, for my y values heading up, this graph is going to keep going up forever. So it's going to go to +infinity. And then heading down, notice the lowest this graph ever goes is -infinity. It's going to keep heading down forever. So that's my domain and range. Now this is the important key point that I want you to notice. If you look at this, do you notice how the domain of my original function became the range of my inverse function? And the range of my original function became the domain of my inverse function. That will always be true. When I find an inverse function, the domain and range will switch every single time because I'm switching the x and y. Last but not least, I want to know if my inverse is a function. So I'm looking at this red graph that I've drawn, and I'm going to draw just straight up and down vertical lines on this graph. And can you see how I'm hitting that graph more than one time? Which means that no, this inverse is not a function. So hopefully that helps you with those two. I'm going to go ahead and do a second video with a few of the equations down at the bottom. But hopefully that helps you and you can finish this assignment.